Welcome back. In session 1, we set two expressions equal because both of them were already equal to y. That was the easy case. Today we handle the general case, and the tool is called substitution. Substitution is the single most important algebra move in this entire course. The goal never changes. Take a system with two variables and collapse it into one equation with one variable. Once you're down to one variable, you're just solving a quadratic, and you already know how to do that. So today, how to choose what to substitute, how to do it without breaking the algebra, and how to answer the specific questions the SAT builds on top of it. First, decision. Which variable do you isolate, and from which equation? The rule is simple. Pick whatever creates the least mess. Look for a variable with a coefficient of 1, because isolating it costs you nothing. Take 2x plus y equals 8. The y is sitting there with a coefficient of 1. Subtract 2x from both sides, and you get y equals 8 minus 2x. Clean, no fractions. Compare that to isolating x, which would give you x equals 8 minus y all over 2. Now you're dragging a fraction through the rest of the problem. Same answer, more chances to slip. So scan for the coefficient of 1. Let's run a full example. We have y equals 2x plus 1, and y equals x squared minus 2x plus 5. Both are solved for y, so substitute one into the other. 2x plus 1 equals x squared minus 2x plus 5. Now gather everything on one side. Subtract 2x, subtract 1, and we get 0 equals x squared minus 4x plus 4. Look closely at that quadratic. X squared minus 4x plus 4. That's a perfect square. It factors as x minus 2 all squared equals 0. So x equals 2, and that's the only x value. Substituting into the line, y equals 2 times 2 plus 1, which is 5. One single solution, the point 2, 5. And geometrically, that's beautiful. The line just grazes the parabola at one point. Its tangent. A repeated root and a tangent line are the same fact. Now, the trap that costs more points than any other in this topic. When you substitute, you must replace the variable with the entire expression, wrapped in parentheses. Suppose y equals 3 minus x. And you need y squared. Then y squared is the quantity 3 minus x squared. It is not 3 minus x squared, and it is definitely not 9 plus x squared. Expand it properly. 3 minus x times 3 minus x gives 9 minus 6x plus x squared. See that middle term, negative 6x? That's the term everybody loses. So here's my rule. The moment you substitute, write the parentheses first, before you write anything else. Parentheses are not decoration. Once you have your x values, you're not finished. You need the matching y values. And there's a right way to do this. Always substitute back into the simplest equation, which is almost always the line. Why? Because the parabola makes you square something, and squaring is where arithmetic errors live. The line just makes you multiply and add. One more thing. Each x carries its own y. They travel in pairs. If x equals 1 gives y equals 6, then 1 and 6 belong together. Don't mix and match coordinates across your two solutions. Keep each pair on its own line as you write it down. Now here's a question type you will absolutely see, the sum of the y coordinates. Most students find both points and then add. That works, but there's something faster and safer. Watch. Suppose the line gives you y equals 8 minus 2x. Then y1 is 8 minus 2x1. And y2 is 8 minus 2x2. Add them. You get 16 minus 2 times the quantity x1 plus x2. And x1 plus x2 is just the sum of the roots, which Vieta hands you as negative b over a. So you never need the individual roots at all. You find the sum of the x's from the coefficients, plug it into the line relationship, and you're done. This turns a 3-minute problem into a 30-second one. Here's another one. The positive difference between the x coordinates. Again, you could find both roots and subtract. But there's a formula worth knowing. The distance between the two roots of a quadratic is the square root of the discriminant, divided by the absolute value of a. So, for x squared minus 4x plus 3, the discriminant is 16 minus 12, which is 4. The square root of 4 is 2, and a is 1, so the roots are 2 apart. Let's sanity check that. The roots are 1 and 3. And 3 minus 1 is 2. It works. Notice the word positive in the question. Difference is asked as a distance, so it's never negative. Take the bigger minus the smaller, or just take the absolute value. Let's do one straight from your practice set. The system 2x plus y equals 8 and y equals x squared minus 6x plus 11 has two solutions. What is the sum of the y-coordinates? Step 1. Isolate the easy variable, y equals 8 minus 2x. Step 2. Substitute into the parabola. 8 minus 2x equals x squared minus 6x plus 11. Step 3. Collect. 0 equals x squared minus 4x plus 3, which factors as x minus 1 times x minus 3. So the x values are 1 and 3. Step 4. And this is the part the question actually asked about. Find the y's. Y equals 8 minus 2 times 1 is 6, and y equals 8 minus 2 times 3 is 2. 6 plus 2 is 8. The answer is B. And notice 4 is a trap for people who added the x's instead of the y's. One last habit, and it matters more than it looks. Not every quadratic factors nicely. If you substitute and land on x squared minus 2x minus 4 equals 0, that will not factor over the integers. Use the quadratic formula, and you get x equals 1 plus or minus the square root of 5. Now, the temptation is to reach for a calculator and write 3.236. Resist it. The SAT often wants the exact form, and the answer choices will be written with radicals in them. If you round early, you lose the ability to match. Keep the radical all the way to the end. Convert to a decimal only if the question actually asks for one. Let's recap the method. 1. Isolate the variable with a coefficient of 1, usually y in the linear equation. 2. Substitute it into the other equation, using parentheses around the whole expression. 3. Collect everything on one side to get a single quadratic and solve it. 4. Back-substitute into the simple equation to recover each partner coordinate, keeping the pairs together. And the shortcuts, for a sum of y's, use the line relationship together with Vieta's root sum. For the gap between roots, use the square root of the discriminant over a. A repeated root means one solution, and geometrically, that means tangent. Excellent work on session 2. Substitution is now in your hands, and you've seen the 3 questions the SAT likes to build on top of it: sum of the y's, the partner coordinate, and the distance between roots. In session 3, we'll focus on the quadratic itself, how to choose between factoring and the formula, and how the discriminant tells you the number of solutions without doing any of the work.